What is electrode? What is electrode potential? What is oxidation potential? What is reduction potential? So all of it we will be discussing right now. Electrode is a metal rod dipped in the solution of its ions. Metal rod dipped in the solution of its ions is known as electrode. For example, if you have zinc rod dipped in the solution of Zn+2 ions is known as electrode. Similarly, if you have copper rod dipped in the solution of copper ions, then this is called as electrode. So this setup is called electrode. Also, redox couple we call that. Zinc slash Zn2 plus is redox couple. Similarly, Cu2 plus is a redox couple. Alright, or electrode commonly known as metal rod dipped in the solution of its ions called electrode. Alright, next term you will hear is electrode potential. So electrode potential is the because of the charge, natural charge, which when dipped, a particular rod is dipped in the solution of its ion, it gains naturally either positive or negative. So because of the charge on the metal rod and the charge in the solution, there is a potential difference. The potential difference between the rod and the solution is commonly known as electrode potential. What does it tell us about? Electrode potential usually tell us about the tendency to gain electron or tendency to lose electron. If reduction potential of a metal is more, that means tendency to get reduced for that metal is more. If reduction potential of a metal is less, that means tendency of that metal getting reduced is less. So that metal will get oxidized. Reduction potential less, that means it wants to oxidize, not reduce. If reduction potential is more, that means it wants to get reduced, not oxidize. Reduction potential more, tendency to reduce more. Oxidation potential more, tendency to oxidize more. So if one thing is more, other will be less. So if reduction potential more, oxidation potential will be less. And what is the relation between them? Relation is exactly opposite. Reduction potential is minus of oxidation potential, or oxidation potential is minus of reduction potential. Alright, now let us check out few more things. So if you have two electrodes, let us say if we have oxidation electrode and reduction electrode. So what is the difference? At oxidation electrode, oxidation is happening, at reduction electrode, reduction is happening. So in a galvanic cell, a cell through which redox reactions happen, and through chemical reactions we get electrical current. Galvanic cell, we get electrical current through chemical reactions. In another way we can say conversion of chemical energy into electrical energy is happening in galvanic cell. So in galvanic cell the charge on anode is negative and charge on cathode is positive. Whereas in electrolytic cell where electrolysis is happening, exactly opposite is the charge. In galvanic cell, anode is negative, cathode is positive. In electrolytic cell, anode is positive, cathode is negative. But in both the cases, one thing is same. What is that? In both the cases, oxidation occurs at anode and reduction occurs at cathode. This is universal. This is universal, be it electrolytic cell or galvanic cell. So electrode potential can be oxidation electrode potential or reduction electrode potential. So if we have to write oxidation electrode potential, how we write that? For example, for a metal M, we will write oxidation electrode potential like this, M to M plus. If we have taken standard conditions, what is the standard conditions? Concentration of plus or minus ions to be 1 molar and temperature to be 298 Kelvin. So its standard conditions are like this. The standard conditions are temperature 298 Kelvin, 298 Kelvin, and pressure, partial pressure equals to 1 bar, or concentration of a particular species, concentration of a particular ion equals to 1 mole, and these are standard conditions. If we are measuring electrode potential under these standard conditions, this is under normal conditions you will write this. Under standard conditions, oxidation potential you will write this. Everything will be same. Just to represent the standard condition, we will put a knot out here. So E₂ means conditions are standard. So M to M plus oxidation is happening, standard oxidation potential. E₂ M to M plus. So this is oxidation potential representation, normal condition under standard condition. Similarly, you can write reduction potential. Reduction potential I can write M plus to M, gain of electron, right? So gain of electrons, so from positive to neutral. So gain of electron. Under normal condition, I will write reduction potential like this, and under standard condition, I will write E₂ M plus to M. So this is standard reduction potential, and this is reduction potential in general. So this is our few basic terms which each individual should know before moving ahead in electrochemistry chapter. Thank you.